Hey everyone, my name is Josh, and I run Moonlight. If you don't know what Moonlight is, it's a place for creators at 42 to gather and talk about their projects. So what that means is, if you have a side project, a business, a tool you're making, whatever that is, it's a great place to come share it with the community and get feedback on what you've been working on. And so Moonlight is split into two parts. The first half is an open mic. Anyone can come talk for 5 minutes, tell everyone what they're working on and get some feedback on it. The second half is a demo. And that's about 15 minutes. And if you ever want to do that, just let me know, and I'll get you signed up for one. In addition to that, as a quick note, my time at 42 is nearing its end, so I am always looking for someone to potentially take over Moonlight. So if you want to get more involved, there's no commitment in taking it over, but if you want to get more involved, see how it works, give it a test run, let me know, and that'd be amazing. I think there's a great chance to grow the entrepreneurship community here. That'd be really cool. And so we'll go ahead and get started today. Does anyone have any side projects that they're working on that they want to talk about?
Hello, I'm Sean. I'm working with both Justin and Denton, and we are creating a streaming service where you can stream from your desktop to a Pi. And as long as you have an Ethernet port you can plug into, you can get to your computer from anywhere. And it's going to be some cool technology. Thank you. We will be showing it off on the 25th, and people will be able to play some PUBG, some Mortal Kombat, whatever's clever, and it'll be good to go. Questions? Concerns? All of the above? It's built with some open source software, and I'll have to get better details on that momentarily.
Thank you. All right, does anyone else have any projects they want to share? All right, if not, we can go ahead and get into a demo tonight. So, are you ready? All right, are you ready for demo? All right, yep, we can go ahead and get started on that. Be a short one this week. So this is like more numbers. I got it. Yeah, okay.
I'll probably just hold this thing. Thought I might. Believe in you, mostly. Is it not outputting? Yeah, all right. So my project is a tool called Cell CSS, which is for rapid web development and just web development in general. It's for generating CSS off of your HTML class names. Oh, it's loaded. Perfect. So yeah, here's the slogan we have here: web design in real time. Here's some CSS from YouTube, actually. And as you can see, it's pretty complicated. You've got, like, for example, this class, YTD notification top bar button renderer, that's pretty verbose. And then below that, you've got this class, which is whenever there's a force button icon in the same element as YTD notification top bar button renderer, and also if there's a tag inside with the YTD notification top bar button renderer class, then it does this. And then below that you've got this, which is the same as that, but it's an additional rule that only happens on this particular part, and it can't be in that main group because that main group also has this condition, and so we can't have that condition happening when that's happening. And the way this kind of CSS dependency mess happens is when you're designing a website, you usually have some idea about what it's going to look like, and so you start making some classes that are going to be helpful for that. And even just as you're designing it, you might realize that the real world isn't as friendly as your imagination, so you make a few more classes, and then you change your design later on, and so you make classes that modify your original classes, and it gets very complicated. And so every once in a while you've got to refactor, and that takes a lot of time. And when you get to something the size of YouTube, refactoring becomes the majority of what you're doing when you're managing your CSS. So instead of writing CSS, you're managing CSS, and at that point, everything's really slow. So there's a few solutions people have thought up to this. One of them is atomic classes, functional classes, sometimes they're called as well, where you just put every individual CSS rule has its own class. And so you have these absolutely gigantic CSS files, and each one of them, each one of those classes is something like height 100 or height 50. And so height 100 class makes the height of that particular tag 100%, and then the height 50 makes it 50%. And that's pretty good. From a designer perspective, it's really easy to use because you don't actually have to switch between two files when you're designing. You can just kind of work in the same HTML file, and what you stick on to the HTML tag is exactly what you get at the end, so that makes it easier. But then you also have these giant, like 3,000 line CSS files for very simple websites, and that's terrible. So there was a Yahoo project called acss.io, which tried to fix this problem, where instead of having a giant library of simple CSS classes, you just generate them based on the class names people have. And that project is really great. Mine's better. So these are the reasons why mine's better. It's configured in YAML. The original was configured in JSON. JSON is not nearly as easy to use as YAML if you ever use both of them. Mine's a lot faster. Mine's like 30 or 50 times faster than theirs, and that's because theirs is written in Node. Mine's portable, and mine's written in Haskell. The portability is really nice because you don't have to download npm install and then run npm install, which takes, like, for this particular project, like 5 or 10 minutes. You can just download my statically compiled binary and just use it right away. And it doesn't have Node.js. I don't know if you've ever installed a large Node.js project, but it's kind of ridiculous. You get this deal where you have your 50 dependencies for your Node.js project, and then each of your dependencies is like, all right, I'm a really simple library that manipulates strings. I think maybe 60 dependencies is a good number for that. And then each of your dependencies is like that. So it gets pretty ridiculous. This particular project, ACSS, has over 1,000 dependencies in total. That's because each of its dependencies has dependencies, and then those dependencies in turn have dependencies. And so when I was originally designing this tool, I wasn't. I was just going to use ACSS because the designer working on the project that spawned this project, I'm going to call him designer person. Designer person really, really wanted to use ACSS because he thought it would make his design workflow much easier. And it definitely would, but as soon as we tried to integrate it with the project, I was just sitting there and I'm just watching these thousands of dependencies install, and it hurt me. It wasn't a good thing to watch to my beautiful Haskell code, having thousands of JavaScript files being downloaded slowly over HTTP. So I made Cell. This is what Cell does. Here are its options. So you can just give it a path or a file specifically, and then it will just print out standard output, the generated CSS. And so this is its little usage page. This is the documentation site for Cell, and this is available on cellcss.com. Because all the classes that it generates use a shorthand for that generation, the documentation site provides like a really easy searchable resource so that if you don't remember a specific class, for example, BD translates to border. You might not remember that, so you could search border, or you could search BD, or you could search pretty much any combination of anything, and it would fuzzy search and match it for you. And then you can actually click the descriptions of each of those classes, and it will link to MDN. So if you don't remember how to use that particular CSS property, that might be nice. So of course, this documentation site's made with Cell because you don't make a web technology and then make the site for that web technology not use your tool. It's just, you don't do that. So as you can see, this header here, it has some cells on it, and those are highlighted in color now. So if you look at the first one, you can see it's M, uppercase M, and then inside the parentheses we have S01. So what that S01 is it's a variable, which is one of the features of Cell. Because one of the problems with normal like atomic CSS is you have a ton of classes, and they're very fine-tuned, but sometimes you want to have less options. You want to have like a few colors that you use for your whole project, or you might have a few sizes that you want to use everywhere. And so you could just do that manually, but it's nice to have variables. So in the YAML file, you can define variables to make things easier. So as you can see here, designer person has found a scaling size that they like. So like there are certain sizes that look pleasing to the human eye and certain ratios that people who made books discovered over many, many years. And so that's what he's using here. And as you can see, S1 is being translated to 0.833 rem, which stands for root M. And you can see that the generated class in this case would be this. Then we look at the next one. We have FWB. So what does that mean? Well, if we look on cellcss.com, we can see that font weight, which is the name of FW, generates the font weight CSS property, and the B is an alias for font weight bold, because you don't want to have to type out bold every time, since that's something that you're going to be doing a lot for font weight, since it's one of the most used properties. So Excel has a lot of these aliases. They're very nice. So for example, if you're setting a border, instead of writing out solid, you can just put S, and it will translate it for you. So that will generate to this class again. And then if these last one here, which is FZ, which stands for font size, maybe you want to just put in your own custom size. You can do that. This is how it works. It would just generate a class like that. And if you want, for example, to have only size 2 rem when you're hovering over the header, you can just append a little h, a colon, and then a little h there, and then it will generate a class that only applies on hover. So that's nice. And the advantage of this kind of design is that you're only staying in one file the entire time. And when you're in one file, you're not switching context. And as we know, as computer scientists, there's a cost to switching contexts. And since we're not, it's very easy to just stay in that one file, slowly work your way down, and add your CSS. And you don't have to look up in the other file your classes. Like, say you've been working with this project for a long time, or maybe you're just starting out in this project and someone else has been designing it before you. You don't have to look up their CSS. You don't need to memorize their class library, because it's all right there. All the information you need to know about what it's doing is in the classes, in the class names. So that's really convenient. And so the documentation site's available on cellcss.com. You can download this today and try it out if you want to. It's been a great project. I learned a lot about Haskell doing this project. Haskell's kind of an interesting language because it doesn't really like I/O. It actually wraps I/O in a mathematical concept called a monad, so that was a fun little tidbit to learn about. I use this tool pretty much every time I make a website. The only websites I wouldn't use something like this on is if it's just like a research paper or something where it's just text, because that's a kind of website that the original and design intent of CSS works very well on. CSS doesn't really work very well for UI. It doesn't work well for UI because it was made for text, just plain text with styling. So yeah, after this point, let's open it up to any kind of questions you might have about the project. Yeah, I'd be definitely willing to do that. I think that'd be great. If you know CSS, really you're just learning that translation. It's not like you're learning a new language or anything like that. Any more questions?
So there's not, I mean, this, actually, it's not really much of a question, more or less, just, I think it seems like it's a pretty nice thing, because I know with a certain framework, Twitter Bootstrap, like they have all their whole grid system, and it becomes a complete mess to use, and it looks like with Cell CSS, it actually can configure the sizes and create your own system out of the config file. Actually, just a question now because of this one. So how do you compile all the files together so that it generates the CSS with that tool? Do you just pass the names now, or?
All right, so that's a good question. So what it's doing behind the scenes, and I thought about actually talking about how it works technically, but I think I really wouldn't have enough time. If I had known that I was going to be the only presenter, I would have talked about it a bit more. So what it's doing is it's going through all the files, and actually in the cell YAML, you can decide what the extensions, cell should look at. So for example, if you're using some other templating language, like for all of my sites, I use Mustache. which I use the abbreviation .mu for, that you can do that, so that's fine. Or maybe you have some JavaScript that contains that generates CSS, like this site. Well, this site's actually looking at a JSON file to generate the rules for the generated part of the site, because the documentation is actually being generated off of a large JSON file that contains a lot of information, because writing all that out would have taken forever. So anyway, the way that it's actually looking for these rules is there's a certain set of delineators which it counts as like spaces, basically, and it just splits everything. Because it's Haskell, we can do this. It splits everything up into a giant list based on that. And then it just puts it through, and it checks if it meets certain requirements, so that it determines that it's a cell. And if it meets those requirements, it'll run it through the hash map and see if there's a member of the hash map that contains that member. And then it'll add that to a list, and at the end, it just goes through the list and removes duplicates. So that's not a very efficient algorithm, and there's probably a faster way to do it. But this was actually the first project I ever made in Haskell, and this was almost 2 years ago. And compared to the Node.js implementation, it is like 30 or 50 times faster. So it's good enough for my use, especially since this is the kind of thing you're probably going to run once, or if you're using the watch mode that Cell has built in. So if you make changes to your HTML, Cell will automatically regenerate your CSS, so you can just refresh the page. That's just a convenience function it does. It's fast enough for that. Like, there's no noticeable delay. It takes like less than a second to do an arbitrary number of HTML files. Another feature it has with the -m flag is it will minify your CSS. So for like a pretty complicated site, I was actually kind of surprised. Originally, when my designer person was talking about using a CSS, I was worried, because I was like, well, if you're going to have all these little individual CSS classes, isn't the CSS file just going to be huge? Well, it turns out that's not really true, because like say you have height 100% on one element. Well, that's actually going to be used a lot of different places, so it's not going to be regenerated each time. It's only going to appear once. So for like that whole documentation site, there's only 60 classes. That's it. That's all it took. And with minification, that's smaller than almost any other CSS framework you're going to see. And another feature of Cell is it actually will vendor prefix for you, so you don't have to run it through anything. It'll vendor prefix and minify, and you're just good to go. That was actually way bigger than the scope of your question. If anyone else has any other questions? So the source code is all published, and that's on Bitbucket, and you can actually find links to that on cellcss.com. Designer person and his friends in Germany have used it. They've been using it for about a year now. They enjoy using it. I'm definitely looking for feedback from other people, which is one of the reasons I decided to do this Moonlight, actually. If someone else tries using it for like a project here at 42, or maybe a hobby project, and has feedback for me, I would greatly appreciate that. That's actually another reason that it would be good to do a workshop if people are interested. Yeah. Is that the last question? All right, thank you very much.